from semiconductor devices, right? Half wave rectifier, full wave rectifier, and NAND gate and NOR gate truth table we have studied, right? So now today we will going to be discuss about another chapter from another chapter, SAQs only again. So already we have covered what are important LAQs we covered. So now we are covering all SAQs from important questions from different chapters. Okay. So let us today we discuss from chapter of atom. From chapter of atoms, SAQs will discuss. SAQs. So mainly from this chapter, we have three SAQs we have, like explain the different spectral series of hydrogen atom. Second one is what are the limitations of Bohr model. And third one is explanation of de Broglie's for the Bohr second postulate. De Broglie's explanation of Bohr second postulate. So these are the three which are important questions the atom. Okay. So let us we discuss what is first SAQ, that is different spectral series. Different spectral series of hydrogen atom. Different spectral series of hydrogen atom. We know that in hydrogen atom, there are 5 different spectral series are there. What is a spectrum? A spectrum is a band of wavelengths. A band of wavelength, a group of wavelengths. A spectral series means there is a continuous spectral lines are coming. So we know that in a hydrogen atom or generally in a hydrogen like atoms, different energy levels will be there for the electron. In electron, different orbit, different energy is there. And we know that an electron is jumping from lower energy level to higher energy level. Lower to higher it is jumping or exciting to higher energy level. So it absorbs energy. It absorbs energy. That means we need to supply energy. Then electron in that particular orbit, it will absorb and excited to the higher energy level. That is basically absorption spectrum we call. But when it is excited to higher energy level, okay, then again it make a transition from higher to lower energy level. Higher to lower energy level. For example, we have different energy levels we have. N equal to 1, 2, 3, 4, 5, 6, so on. So many energy levels we have. And first level we call ground state. Second level we call first excited state. And so on, remaining excited states we call. Then whenever an electron makes a transition from higher to lower, excited state to lower energy level, then it will emit some radiation. It will emit some radiation that is in the form of electromagnetic radiation. Electromagnetic radiation. So this different electromagnetic radiation emitted by electron, when it makes a transition from higher to lower energy state, we call it as different spectral series we call. There are 5 spectral series we have. How many are there? 5 spectral series we have in hydrogen atom. So how, when, what kind of spectral series can get? For particular spectral series, the electron has to be make transition from which level to which level. which energy level to which energy level it has to make the transition means. So for this, you see, just I'll explain, you see, I will show, after that I will say what are the points we need to write for answer, but first explanation you listen. So there are different energy levels are there. I took here 7, 8, 9 like this also, 7, 8, 9 energy levels are there. In that, if an electron makes higher energy level to ground state, higher to ground, that means n equal to 1 is the ground. Then n equal to 1 is the ground, leave the ground and remaining higher energy level you take. That means if you make a transition from 1 to, wait. So this is first, second, third, fourth, fifth, sixth, 7, 8 and so on. Many energy levels are there. But in that we have taken few. This is n equal to 1, 2, 3, 4, 5, 6, 7, 8. So I have told that whenever an electron makes a transition from higher energy level to lower energy level, it emits a radiation in the form of electromagnetic radiation, and from one level to other level it will come, one line will come, one radiation line will come. Like that, a series of lines will come that may be lies in different regions of electromagnetic spectrum. Like in electromagnetic spectrum, we have different regions: ultraviolet, visible, infrared, basic region we have. So these are the lines which are emitting during the transition from higher to lower energy level. They may lies in any one of the region of electromagnetic spectrum. And a particular series lines we call particular series we have. I told there are 5. There are 5 series. There are 5 series. What is first series mean? The first series is whenever electron makes a transition from higher energy level to ground state, higher to ground or higher to first energy level or first orbit. That means what? Electron comes maybe from 2 to 1, 3 to 1, 4 to 1, 5 to 1, any higher than 1 to it coming to 1 only. So that is 2 to 1, 3 to 1, 4 to 1, 5 to 1, all are comes to ground state only, higher level to ground state coming. All these lines, all these transition makes any lines, and that lines call it as one series, and that series we named as Lyman series. What series? Lyman series. That means Lyman series, it lies from higher to ground state. Higher to ground state. Like this. This is Lyman series. Lyman series. For any series or any radiation, the particular wavelength of radiation, we can write the wavelength of radiation, that is 1 by lambda, that can be written as that R. It is a Rydberg constant into 1 by n1 square minus 1 by n2 square we call. N1 is a N2 is a higher energy level and N1 is a lower energy level. From where from which orbit it's coming into which orbit? Higher to lower. Higher one is N2, lower one is N1. But coming to the Lyman series, you see, lower energy level, electron coming from 2 to 1, 3 to 1, 4 to 1, 5 to 1, and so on. That means electrons are coming from higher, but into 1 only. That means what? For Lyman series, the higher energy level may be 2, 3, 4, 5, 6, 7, 8, 9, anything. But the lower energy level, electron is coming into the lower energy level, that is fixed to 1, and that is n equal to 1. N equal to 1. That means electron coming from higher to 1. higher to 1. That higher one is anything other than 1. Higher one is anything other than 1. That means N2 value can be any value you can take apart from 1. Then in this one, for Lyman series, you see, for Lyman series, electron electron makes transition from higher orbit to first orbit. Higher orbit to first orbit. That means that is N1 is 1, but N2 is 2, 3, 4, and so on. Anything you can take. Clear? Then this corresponding wavelength you want to write 1 by lambda into 1 by lambda is equal to R into 1 by N1 square, that is 1 square, minus 1 by N2 square, that will be N2 can be take 2, 3, 4, 5, anything you can take. Clear now? The Lyman series will get when electron makes transition from higher to first orbit or ground state. And the equation for wavelength is 1 by 1 square minus 1 by N2 square. N2 will be these values. And all these lines of Lyman series are approximately the wavelength are related to ultraviolet radiation. Smaller wavelength will be present, and that belongs to ultraviolet radiation. It lies in UV region. UV region, ultraviolet region. Clear now? Now coming to the second series after the Lyman series. Second series is electron makes transition from higher energy level to second orbit. Higher energy level to second. That means 322, 422, 522, 622, like that. Higher than 2 to second orbit. So that series we call it as Balmer series. What we call Balmer series. That means it comes from 2 to 3. Sorry, 3 to 2, 4 to 2, 5 to 2, 6 to 2. That means higher level to 2 it will come. This kind of series we call it as Balmer series. Balmer series. That is, electron makes a transition from higher orbit to second orbit. Higher orbit to second orbit. Simple. So for Balmer series, you see, electron makes transition from higher to second orbit. Second orbit. That is N1 in this situation 2, it's a fixed one. But N2 is 3, 4, 5, so on. N2 is 3, 4, 5, 6, 7, anything you can take after 2. Then wavelength, if you want to write that again, same 1 by lambda is equal to Rydberg constant R 1 by N1 square, that is 2 square, minus 1 by N2 square, that can be taken as any value from 3, 4, 5, 6, 7, anything. Different lines will come. All these lines together we call Balmer series. Balmer series. And we know that this Balmer series lines, which are little bit greater wavelength than Lyman series. Little bit greater wavelength than Lyman series. Lyman series lies in UV region, but Balmer series lies in visible region. Visible region. Okay. So that means you can write here, it lies in visible region. Visible region, greater than the UV radiation, ultraviolet. Is it clear this? Lyman series makes transition from higher to first. Balmer series makes a transition from higher to second orbit. Lyman series lies in a UV ultraviolet region and Balmer series lies in a visible region. Okay. Now coming to third one, that means electron make a transition from higher to third one, higher to third orbit, higher to third orbit, like this you see 4 to 3, 5 to 3, 6 to 3, 7 to 3, like that. Higher to third orbit coming, then all together this series we call it as Paschen series. Paschen series. And again the Paschen series also, it is greater than the wavelength of Balmer series, and that is generally lies in infrared region. Infrared region, IR region we call, IR region. So this is the third series, we call it as what series it is? Paschen series. So transition from where to where? Tell me, electron transition from higher to third orbit. Higher to third orbit. That means greater than 3 to 3. That means N1 will be 3, N2 will be 4, 5, 6, 7. Yes or no? Clear? Now from this, the wavelength you can write 1 by lambda, that is equal to Rydberg constant, 1 by N1 square, that means 3 square, minus 1 by N2 square, that may be 4, 5, 6, 7, anything you can take. And it lies in, just now I told it is greater than the visible. So greater than visible means infrared. Infrared. It lies in IR region, that is infrared region. Infrared region. Clear now? Next. We have, I told 5 series are there. So in that I explained already 3. Now 2 more are there. Similar sequence only. So up to 3 means Paschen. So now fourth one is 4. Higher to 4 it will come. That means the line which is electron make a transition from 5 to 4, 6 to 4, 7 to 4, 8 to 4, like that. This series we call it as bracket series. Bracket series. Clear? The electron make transition from higher orbit to fourth orbit. Higher orbit to fourth orbit, bracket series. Bracket series, that is electron make transition from higher to fourth orbit. Higher to fourth orbit, that is N1 is equal to 4, N2 is 5, 6, 7, so on. Clear? That means N1 is 4 square, N2 will be anything from 5, 6, 7, 8. So the wavelength of this corresponding series, I can write 1 by lambda, that is R Rydberg constant, 1 by 4 square minus 1 by N2 square. And again, it lies, whatever the region Passion series lies in infrared. But infrared is greater than red color too, up to longer wavelength radio waves, it has infrared region, more longer infrared region, shorter infrared region we call. But instead of simply we can write infrared region, not a problem. So it lies also in infrared region. Infrared region. Clear now? Passion series. Transition from higher to fourth orbit. Now the last one is simple. It makes the transition from higher to fifth state. Higher to fifth state. So this is called P-fund. P-fund series. P-fund series. Clear? So P-fund series means it makes a transition from higher to fifth orbit. Higher to fifth orbit. So that I will write at this top. So this is a question already you know the different spectral series of hydrogen atom. It is atom chapter, it is there. So I'm rough this one. I will write that last P-fund series here. Okay. P-fund. Transition from higher to fifth orbit. That is N1 is 5, N2 is 6, 7, so on. And 1 by lambda, the wavelength is Rydberg constant 1 by N1 square, that is 5 square, minus 1 by N2 square, that may be 6, 7, 8, 9, so on. And again, it also lies in, IR region. Passion bracket P-fund lies in infrared region. Visible Balmer series in visible region. Lyman series in ultraviolet region. Okay. So you need to how to express this answer. You see, 5 series we have. 5 series, how it will come in? Generally, electron make a transition from higher to lower, series will come. Then higher to first orbit means Lyman, UV region. Higher to second orbit means next series, that is Balmer series, visible region. Higher to third orbit means the third series called Passion series, lies in infrared region. Higher to fourth orbit means bracket series, lies in infrared again. Last one is P-fund series, which makes transition from higher to fifth one. That also lies in infrared region. Each and every series commonly higher to first, higher to second, higher to third, higher to fourth, higher to fifth. That line is fixed. And in every series, N1 is 1 for Lyman, 2 for Balmer, 3 for Passion, 4 for bracket, 5 for P-fund. Then N2 will be as it is, N2 will be the same. Then I told light in UV, visible, infrared, infrared, infrared. Simple question. Is it clear now? Any doubt in this question? Any doubts are there regarding this question? You can raise your hands. And you can ask before you proceeding to next question. In this question, any doubts are there? You can ask. Any doubt? Those who have doubt on this question, they can raise their hand. Okay, good. So now we'll proceed to the next question from the same chapter. That is also very simple question only. That is limitations of Bohr's model. Limitations of Bohr's model. So we'll see now the another question from the same chapter, limitations of Bohr's model or limitations of Bohr theory of hydrogen atom. Bohr theory of hydrogen atom or Bohr model also we can say. Right. Question is limitations of Bohr's model. Limitations of Bohr's model. What are the different limitation? Limitation mean drawbacks we can call. Drawbacks or which cannot not explain something like that, which is failed to explain by the Bohr model or drawbacks of Bohr model you can see. What actually limitations means? We know all everyone that Bohr model, according to the Bohr model, Bohr's model is given as a 3 postulates in the form of postulates given. So what is first postulate? He said that in an atom, we know nucleus will be present at center of the atom and electron will revolve around the nucleus. The first postulate is said by the Bohr is electron revolves around the nucleus in a circular orbit. In a circular orbit is said. Okay. Second thing is when an electron revolves around the nucleus, when electron revolves around the nucleus is said the angular momentum of the revolving electron, the angular momentum of orbiting electron is quantized. That means the angular momentum of revolving electron is the integral multiple of nh by 2 pi. nh by 2 pi or h by 2 pi, integral multiple of h by 2 pi we can say. So that is the angular momentum of the revolving electron is nh by 2 pi, quantized. That is the second postulate. Then third postulate is given as, just now we said the series, right? Based on that only. When electron makes a transition from lower to higher, it will absorb energy. And when it makes a transition from higher to lower, it will emit energy. The absorption of energy when it is going from lower to higher, emission of energy from higher to lower is exactly equal to the difference of the energy levels. That means from 2 to 5 it is excited. The difference between 5 and 2, how much energy difference will come? That much of energy equivalent radiation it will emit. or it will absorb that amount of energy to excite it to higher energy level, or it make transition from higher to lower. This is third one. These are not limitation, just they are explained by the Bohr model. Okay, he applied this three postulate for the successfully for hydrogen atom. These three postulate successfully applied for hydrogen atom, and explain all these three also. Then what are the drawback of this model mean? One by one I will say orally, then I will write on the board what are the things we need to express in the answer sheet. First of all, he said electron revolves around the nucleus, correct? Electron revolves around the nucleus, he said. This is nucleus, positive charge. Around that electron is revolving, and he assumed that his orbit is circle. His orbit is circle. Orbit is circle. So why it is a circle only? Is not given any reason. He assumed that the electron revolve around the nucleus in a circular orbit. That's it. But why it is choosing only circular orbit? Why can't any other shape? Maybe elliptical shape, right? Why can't? Why not elliptical? Only it is circle. It's not given any reason for the choosing a circular orbit. It's simply assumed that, and it is said it is a circle, but there is no particular reason is given for making that orbit is circle. One of the limitation. Second one is, another limitation is, these three postulates are applied for successfully for hydrogen atom and also successfully for hydrogen-like atoms. Hydrogen-like atom means in the sense, in hydrogen only we have one electron. In hydrogen atom only one electrons are there. One electron only there. So it is this limit Bohr model successfully applied for hydrogen atom because it has consist of one electron, and also it is applied for hydrogen like atom. That means the atom consists of only one electron. But this model is not applicable for the atoms whose energies, electrons more than one electron. The atoms having more than one electron. Whatever the atom which are having more than one electron, these Bohr models are not applicable or not explain the spectral lines emitted by or electromagnetic radiation emitted by electrons in an atom which has greater than one electron. The atom having greater than one electron does not explain by this model because it is applicable only for hydrogen-like atoms only. For example, helium is there. Directly helium cannot applicable because helium consists of two electrons. So in that one electron we should ionize, and then after we'll be left with the one electron. So helium plus we call. Helium plus why we'll write? Because one electron already removed. Then only one electron is left in helium plus. Then we can apply Bohr model. Clear now? So that means there's a second limitation that the spectral lines emitted, not explained by the spectral lines emitted by atoms having more than one electron. Third one, it does not explain about the relative intensities in spectral lines. Relative intensities in spectral lines is not explained by this. And also hydrogen atom, spectral lines emitted by hydrogen atom also is not explained by different series of spectral lines emitted by hydrogen atom is not explained by this Bohr's model or Bohr's atomic model for hydrogen atom. So these four limitations we should write under the limitations of Bohr's model, right? So one by one I will write on the board, you just note down. Okay. First one. It could not explain spectral lines, spectral series of atoms having more than one electron. It could not explain the spectral series of atom having more than one electron. One electron is there, it can explain, but more than one electron is there in atom. That atom also emitting a different spectral series, but is not explained by this Bohr model. First limit. The second limit is it could not explain fine structure of spectral lines in radiation spectrum of hydrogen atom. Could not explain the fine structure of spectral lines in radiation spectrum of hydrogen atom, not explained by this theory or this model. Next. It could not explain the relative intensity in radiation spectrum and the next one is it could not explain the wave nature of particles. You know, dual nature of matter is there. So matter can behave like a wave and it behaves like a particle nature. So wave nature is not explained. So it could not explain wave nature of electron or particle. Clear? So could not explain the spectral series of atoms having more than one electron, could not explain the fine structure of spectral lines in a radiation spectrum of hydrogen atom. It could not explain the relative intensities in radiation spectrum, could not explain the wave nature of electron. Then just now I told one, it not explain about why it chosen circular orbit. Why it is chosen circular orbit? Why not another shape? Any other shape. So it could not explain it is not, it is not given a reason for orbit to be circular, and why not any other shape? It is not given a reason for orbit to be a circular, and why not any other shape? It is given as a circular orbit, but why it is only circle? Why can't it the elliptical? It's not given any reason for the circular orbit. It's just like it chosen a circle, but it is not given any reason regarding it choosing a circular orbit. And why any other shape? And why not? We have to write why not. Why not any other shape? Clear now? Students, is it clear? Limitations of Bohr's model, one of the important question in the last exam also it came. It could not explain the spectral series of atoms having more than one electron. It could not explain the fine structure of spectral lines in radiation spectrum of hydrogen atom. It could not explain the relative intensities of in the radiation spectrum. And it could not explain the wave nature of electron, and it not given any reason for orbit to be a circular. Why not it is any other shape? These are the 5 limitations we need to write for the answer. Clear? Is it clear, students? So last few minutes are left. So any other doubts are there, you can ask me now. So one more question is there from the atom chapter that we will discuss tomorrow, along with SAQs of EMI, electromagnetic induction. We'll discuss tomorrow one of the question from atom and other from the important question from EMI chapter, electromagnetic induction chapter. Okay. Any doubts? So students, you have doubts, can you can raise the hand. Somebody told yesterday, so I have a doubt, sir. I will ask tomorrow like that. Is that today present?
Yes, sir, I am present. Today in this chapter, I don't have any doubt.
Today?
In this chapter, I don't have any doubts, sir.
Okay, and from atom, you don't have any doubts. Okay, those you have doubts, you can rise. No problem, good. Okay, so we'll continue tomorrow. So along with one question from atom chapter and other from the EMI chapter. Clear? Right.